December 10th, 2022. Stockholm Concert Hall. 3 physicists walk onto a stage to collect the Nobel Prize in Physics. Standard ceremony, black ties, applause. But buried inside the official press release from the Royal Swedish Academy of Sciences was a single sentence that should have led every newspaper on Earth. It didn't. The sentence stated that the experiments had proven, beyond any remaining scientific doubt, that the properties of particles do not exist before they are measured. Not might not exist. Not we are uncertain. Do not exist. When I went back and read that citation word for word, not the press summary, the actual document, I had to put it down. Because what the Nobel Committee published that day wasn't just a physics award. It was a formal scientific declaration that the universe, at its most fundamental level, has no defined state until something interacts with it. That is not a metaphor. That is what the experiment produced. And if you have spent your life assuming that reality is solid, pre-existing, and independent of you, physics just ruled that assumption permanently out of bounds. The question is not whether reality is real. That question has been answered. The question is what you do with a universe that turns out to be waiting for you. The world before the verdict. In 1935, a man named David Bohm was studying physics at Berkeley on a scholarship. He read Einstein's papers. He accepted the standard model of reality that every scientist at the time accepted. And that model had a name: local realism. Local means no influence travels faster than light. Causes come before effects. Nothing reaches across space instantly. Real means objects have definite properties, whether or not anyone is looking at them. Your keys are in your coat pocket right now, whether you check or not. The moon is there when nobody looks. This is not just common sense. It was the operating system behind every scientific breakthrough, from Newton to the microchip. And it felt airtight, because every single day it appeared to work. Bohm eventually broke from Einstein on this, but the man who never did, who defended local realism until the very end, was Gerard 't Hooft. 't Hooft is a Nobel laureate in physics from Utrecht University, one of the most decorated physicists alive. His argument was never that quantum mechanics was wrong. His argument was that it was incomplete, that beneath the apparent randomness of particles, a deeper deterministic layer had to exist, hidden variables, a clockwork underneath the chaos. He called his framework superdeterminism, and a significant portion of the physics community stood with him. This is the detail most YouTube videos skip. The debate that 2022 settled was not between scientists and mystics. It was between 2 Nobel Prize winners with irreconcilable views of what reality is made of. David Deutsch, Oxford physicist and the architect of quantum computing theory, captured the tension in his book, The Fabric of Reality. Even among physicists who accepted the quantum data he showed, there was bitter disagreement about what that data meant for existence itself. The numbers were not in dispute, the implications were. Think about the last major decision you made, a job move, a financial bet, a conversation you kept putting off. Did you assume the options were real, fixed, and sitting there waiting for you to choose between them? That assumption, right there, is exactly what John Bell put on trial. The trap. Bell makes it mathematical. John Bell was not a believer in quantum mysticism. He was an Irish physicist at CERN who personally wanted to prove Einstein right. In 1964, he published a paper in an obscure journal called Physics, Volume 1, Issue 3. Almost nobody read it for years. What he did inside that paper was philosophically radical. He took the Einstein versus Bohr debate, which had been a philosophical argument with no way to resolve it experimentally, and converted it into a hard mathematical inequality, a number, a ceiling. If local realism is true, the statistical correlations between entangled particles must stay below a specific calculable limit. Exceed that limit, and local realism is not weakened, not challenged, ruled out, mathematically, permanently. Bell himself expected local realism to pass the test. He was setting a trap he believed would catch quantum mechanics. It caught something else entirely. John Clauser at UC Berkeley ran the first real experiment in 1972. The correlations exceeded the Bell limit. Clauser, who had expected to vindicate Einstein, reportedly found the results personally disturbing. Then, Alain Aspect, at the Institut d'Optique in Paris, did something bolder in 1982. He closed the communication loophole, the argument that the particles might be signaling each other inside the apparatus. Aspect switched the detector settings after the photons were already in flight. Real-time communication between particles became physically impossible. The Bell limit was exceeded again. Published in Physical Review Letters, Volume 49, and the physics community went very quiet. Here is the simplest way to understand what that means. Put two people in separate rooms. No phones, no contact. Give each one a sealed card. Ask them to flip at the same moment. Their answers come back perfectly correlated, over and over, far beyond what probability allows. Two explanations exist. Either they agreed on a code beforehand, hidden variables, or the cards had no fixed value until they were turned over. Bell's test was designed to tell those two scenarios apart. The data eliminated the code. The cards had no value before they were flipped. For 40 years after Aspect's results, physicists kept finding technical loopholes. Not because the data was weak, because the conclusion was philosophically catastrophic. One raw number tells the full story. The Bell inequality sets a correlation ceiling of 2.0 in standard CHSH testing. Aspect's result, 2.697. Not a marginal breach, a structural one. The verdict, what the Nobel Prize actually said. Here is what the headlines reported in October 2022. 3 physicists win Nobel Prize for proving quantum entanglement is real. Inspiring, tidy, and almost completely beside the point. Anton Zeilinger's team at the University of Vienna spent years closing the 2 remaining loopholes. The freedom of choice loophole argued that the detector settings might be predetermined by the same hidden variables affecting the particles, making the test circular from the start. The detection loophole argued that unmeasured particles might behave differently than measured ones, skewing every result. Zeilinger's team closed both simultaneously. The methodology was airtight. The conclusion was now inescapable. The particles did not have definite states before measurement. There was no hidden variable. There was no pre-existing fact waiting to be uncovered. The measurement event is not passive. It is generative. It participates in producing the outcome. In his Nobel lecture in Stockholm, Zeilinger stated that the results raised deep questions about the nature of reality. In a follow-up interview with Scientific American, he went further. There is no reality independent of our measurements. The foundational methodology came from Hensen and colleagues at Delft University, published in Nature, volume 526. The first fully loophole-free Bell test, which Zeilinger's team then took to its final, definitive form. When I cross-referenced the Nobel citation with Zeilinger's own lecture notes, what stopped me was not the physics. It was the verb tense. The Academy did not write "might not exist." They used the present tense. Do not exist. In an official scientific document from the world's most credentialed physics body, that is not casual phrasing. That is a verdict. Christopher Nolan's film Tenet, 2020, was built around causality running in reverse, an effect preceding its cause, depending on the observer's direction of participation. Most people called that science fiction, but the logical structure Nolan was playing with, that which version of events you inhabit depends on the direction of your engagement, is structurally closer to what Zeilinger's photons demonstrated than any simulation theory metaphor ever produced. Not because Nolan proved physics, because the physics now rhymes with something people felt but couldn't name. 3 anomalies that now make sense. If the universe does not finalize its state until something interacts with it, then 3 phenomena that seemed like outliers suddenly fit. Start at the cellular level. The Fleming group at UC Berkeley published research in Nature in 2007 showing that photosynthesis in green sulfur bacteria achieves near-perfect energy transfer efficiency. How? Quantum coherence. The plant's energy simultaneously explores every possible molecular pathway in superposition and collapses to the most efficient route upon interaction. Local realism says energy takes one path. It doesn't. Life figured out quantum non-locality 3.5 billion years before Bell wrote his theorem. Non-locality is not a laboratory edge case. It is the mechanism powering every leaf you have ever seen. Scale up to the physiological. In 2010, Ted Kapchuk at Harvard Medical School published a study in PLOS One, demonstrating that open-label placebos, patients explicitly told they were receiving sugar pills, still produced measurable improvement in irritable bowel syndrome. No belief in the treatment required. The observer's anticipatory state produced real biological change in a system that local realism says should be chemically fixed. The observer was inside the causal chain, not metaphorically, clinically. Now scale to the neurological. Your reticular activating system receives roughly 11 million bits of sensory data per second. Your conscious experience gets approximately 40 bits. You are not perceiving reality. You are operating a biological measurement apparatus that selects from a near infinite field of incoming signal and collapses it into one narrow, attention-directed version of experience. That is not poetry. That is the same logical architecture as Zeilinger's detector. The apparatus determines what actualizes from what remains potential. Here is what I find most striking about these 3 exhibits: the plant, the placebo, the brain. None of them were designed to validate Bell's theorem. They emerged from independent research in biology, medicine, and neuroscience. When 3 unconnected scientific fields converge on findings that only make sense inside a participatory model of reality, that is not coincidence. That is a pattern demanding one explanation. So the question stops being whether the universe is participatory. Stockholm answered that. The question becomes what kind of participant you are. The participatory upgrade. John Wheeler was not a mystic. He was the Princeton physicist who named the black hole, developed the concept of quantum foam, and worked directly alongside both Einstein and Bohr. He spent his final decades on one idea: the participatory anthropic cosmos. His argument, published not in a philosophy journal, but in the academic collection Quantum Theory and Measurement, Princeton University Press, 1983, was that conscious observers are not passive witnesses to a pre-built universe. They are active participants in its ongoing construction. Wheeler wrote, "We are not simply bystanders on a cosmic stage. We are shapers and creators of the universe." He built that argument directly on Bell's data, not on intuition, on the math. Robert Lanza, a stem cell pioneer at Wake Forest University School of Medicine, extended this into biology in his book Biocentrism, co-authored with astronomer Bob Berman. His sharpest contribution was the analysis of Wheeler's delayed choice experiment, where photons retroactively decide whether to behave as waves or particles based on a measurement choice made after they have already traveled. The measurement event reaches backward in time to shape the photon's history. This is not interpretation. This is what the apparatus records. Lanza's conclusion: consciousness may not be a product of the universe, it may be a condition for it. Here is what this means in practical terms. If your RAS is a biological measurement apparatus, and Bell's framework establishes that apparatus design determines which possibilities actualize, then deliberate calibration of your attention is not a self-help concept. It is applied physics at the scale of human neurology. What you prime your attention with before a high-stakes decision shapes which version of the available field collapses into your experienced outcome. The HeartMath Institute's peer-reviewed research on heart rate variability coherence training shows measurable improvements in what they call intuitive decision accuracy. In the framework we just built, that is simply a more deliberate calibration of your internal measurement apparatus. Here is what I keep returning to after spending weeks inside this material. Wheeler, Zeilinger, Bell. Not one of them set out to build a philosophy of personal agency. They set out to understand photons, and every single one of them arrived at the same place: a universe that is structurally incomplete without a participant. The Royal Swedish Academy did not hand 3 physicists a medal for proving the universe is strange. They handed them a medal for closing every escape route that let us pretend otherwise. Local realism is dead. The old model of a solid, fixed, observer-independent reality has been formally ruled out by the institution that defines the outer edge of human scientific knowledge. What you build in its place, that is the only experiment left that actually matters.